With this video, I'm just going to show you how to name simple binary covalent compounds. All right, so let's start with the example P2S5. So when you're naming a covalent compound, you typically name in the order that the elements are written. So in this specific example, I'm starting with the phosphorus atom, and I use the subscript to show me how many phosphorus atoms are going to be present in this overall molecule. So when I'm naming the compound, I use the Greek prefix in order to indicate how many atoms are present in that molecule. So for 2, the Greek prefix is di, so this is diphosphorus. Now with the second element in the formula, we use, just like we did with the ionic compounds, we take the root of the word and add "ide" to the end of it, right? So for this one, the root, or the sulfur, is your element, right? The root of sulfur is just sulf. So then you end up adjusting it to be written as sulfide, okay? Now notice this guy, though, also has a subscript here. So this subscript indicates that there are 5 atoms associated with this particular compound. So then we need to use the Greek prefix in order to get to, in order to indicate how many elements are there. So then we write that this, the second part of the compound would be pentasulfide. Penta being the Greek prefix indicating that there are 5. Okay, so now let's do some more examples, just to kind of give you some ideas as to other compounds, what other compounds would be called. All right, so let's take ClO2. Okay. Now the second part of this, and like I've already talked about, would be so you take the root of oxygen, and this is actually just ox, okay? And so this becomes oxide, but there are 2 of them, okay? So the fact there are 2 oxygen atoms with this compound, the second part is dioxide, okay? Now simply, the first part of it, this is a chlorine atom, but there's only 1. So notice there's no suffix here, because if there's no suffix, that just means that there's just 1 atom associated with it. Now when we're naming covalent compounds, if you're starting out with an element that does not have a suffix, you simply just name the element. So this one is chlorine dioxide. Okay. Now if we take another example that's similar to this, right? So now we have Cl2O, okay? So now we have a subscript with associated with the chlorine atoms, right? So 2 chlorine atoms for one molecule. So this becomes dichlorine. Now notice there's no subscript. No subscript on the oxygen here. So now you say it's dichlorine monoxide. Mono being the Greek prefix for just 1. Now notice that I didn't put mono here, right, when it's starting the name, right? But if there's only 1 atom associated with this molecule in the second part of the formula, it's pronounced monoxide. Okay? So we could go even one step further by taking the picture of a molecule, right? We could write out what the overall chemical formula would be. Here we have a selenium molecule bound to 6 chlorine atoms, a selenium atom bound to 6 chlorine atoms, so you have SeCl6. Okay, the 1, 2, 3, 4, 5, 6. Now, if we were to name this compound, again, it is just as if the for the other compounds, we would call this selenium, since there's only one, but it's at the beginning of the name. We don't indicate mono, right? So it's just selenium hexachloride. Hexachloride. And so for all of these compounds, they follow these rules pretty easily, or pretty uniformly. So you can certainly make an educated guess as to what the name of any compound could be if you're doing the systematic nomenclature. And that is how you name binary covalent compounds.